Hey, this is Mr. Ward, and this is your Algebra Exit Ticket 29.1, Week 29, Day 1, video key for B block. And here we go. We're going to create an equation to model this situation. Now, hopefully at this point you are feeling more comfortable with this from quadratics 3. So we want to deal with this situation. Jimbo is selling automatic banana peelers for $700 each, and he can sell 900 of them. So we want to start off with this little structure. It's going to be a product of price times sales. So 700, I'll put a dollar sign in there, and times 900 sales. That's how many he gets, how much money he gets. That's the total revenue he's going to get. And I'll put it over here. Revenue in terms of X will equal this structure. But now we got to deal with how we're dealing with the X. So we know that Jimbo's worked out that if he raises the price $20, he would lose 30 sales. And every time he raises the price $20, so we're going to start with just one raised price and one loss of 30 sales. But it's going to happen X number of times. Anytime he does it, he raises it $20, but he loses $30 anytime he does that. So we're going to make that 30 times the number of times he raised the price, and $20 times the number of times he raised the price. So X equals number of times he raises the price by $20. And we can use that to come up with, I'll come back to this in just a second, but I'm going to first deal with this. But if you are having any trouble on this, it'll be useful to see what that looks like on a graph. I will work that out for you and show you where that leads and why that's valuable. But now we want to find the x-intercepts for this 1, 2, 3, 4 fourth degree polynomial. It's got 4 linear equations being multiplied. So it's going to have 4 x-intercepts. And so we're going to have an x-intercept for x minus 3. It'll be what is the x value that makes x minus 3 equal 0? Well, if x minus 3 equals 0, then x equals 3, because 3 minus 3 is 0. And then if we take the next one, x plus 12, we say that equals 0, then x equals negative 12. And we take the third one, x minus 9. X minus 9, we want to say that equals 0 because we're trying to find out what makes that linear equation equal 0. What x value? Then x equals 9, because that's what will make x minus 9 equal 0. And then finally, x plus 205, you say that equals 0, and then you solve for x, and then we know that x would equal negative 205, because negative 205 plus 205 will be 0. So x-intercepts are at 3, negative 12, 9, and negative 205. And we could graph it, and you will see that they are all at those places. So I'm actually going to do that in just a second. So let me grab this one, and then I'll grab the other one. So open up a Desmos, go right in there. And if we graph that, we will zoom out and we'll be able to see all the x-intercepts. There they are. I'm going to zoom back in just a little bit, drag this over here, and I'm going to do a thing to squish this equation. I can vertically transform the equation by multiplying the whole thing by 1 over some small fractions, maybe 1 over 200. I think I need to make it even smaller, maybe even smaller than that. Okay, so we have an x-intercept over here at negative 205. We have one here at negative 12, like I predicted. We have one at 3, and we have one at 9. So those are all the x-intercepts that we had identified in the last bit. I'll zoom out just a bit so you can see what this looks like. It goes way down there, probably because I've got a 205 in the mix. Let's take a look at our revenue equation. So here we have the revenue equation. I'm going to have to tidy it up just a little bit because of the dollar signs. I'm going to go back to home, put this in here. It doesn't like the dollar signs probably, so I'll get rid of the dollar signs, and I'll say R in terms of X. This is the revenue function. the output of revenue in terms of X price increases, is going to equal $700 plus 20X times 900 sales minus 30 sales for each, and X is for each number of price increases. So we're going to have to zoom out and find that. Oh, there it is. Okay, let me actually zoom in one more time. So that right there is an x-intercept at negative 35 and the one at 30. So I'll zoom out. I'll just remember that in a second when I find the tippy top of this thing. Way up there. So there it is. There it is. Okay, and you can see negative 2.5, and then so it looks like Jimbo's his price is too high already. Okay, so let me move my picture over here, and I'm going to change my x-axis. Now, I noticed that my x-intercepts were at, I think, negative 35 and positive 30. I'm going to make this negative 50. I'm going to tab over to the other one, and I'll make that 50, and now I can see the whole parabola. Okay, so when we look at this parabola, what's interesting is Jimbo has already raised his price too high. So he actually needs to lower his price. I mean, this will model it. You didn't have to work this out. But this tells us that this price right here, when he is selling 900 of them at $700, he's actually making $630,000, but he could make a little tiny bit more if he lowered the price 2.5 times. So let's see how that would look. Okay, but this is the price equation. And what I'm going to do is I'm going to multiply, instead of x, I'm going to multiply that by negative 2.5. Negative 2.5. So that means his optimal price, his best price, is actually $650. So he should lower his price to $650, 2.5 price hike steps down, and he'll have a revenue, because this is the new price times sales, of $633,750. We can do one more thing, and we can take the sales and we can find out how many sales would he have. This is the sales equation if he lowered the price 2.5 times, negative 2.5. Negative 2.5 times is really, that's 20 times 2.5, but negative. So 20, 2.5 20s is 50, and it's a negative 50. So we're lowering the price $50, which gets us here. We're going to actually be gaining customers based on this model. And he's going to gain 75 customers because 2.5 of 30, 2.5 times 30 is 75. So it's a negative times a negative. We end up with 90 plus 75. So this model can let you know that you are already pricing your customers out. Eventually, if Jimbo keeps raising the price 30 steps, he'll end up with 0 customers. So if I make that 30, he's raised the price of $1,300. He will have driven all of his customers away. He'll have no sales whatsoever. And if he lowers his price 35 times, he'll be selling his stuff for $0. He'll have plenty of customers at that point. I think the model is a little broken at this point, but it predicts he'll have 1,950 sales. Of course, the price is 0. He may just have all the sales he wants because people will be happy to take free stuff. All right, I hope this has been a helpful video for you.